Hello. Hello. Hi. Good afternoon, everybody. The next talk is going to be by Mike Turner, and it's about Quasar, as you can see. So, round of applause, everybody.
Hello. When I first signed up to this, I said about 20 people, so I could be a little bit interactive. And then I discovered I was actually on a stage in front of a lot more people, so I had to make some slides. So you may spot in some of the background of some of the photos the ground sheet of my tent. So that's what it is. So we're actually celebrating a birthday, and it's the 30th birthday of LaserTag. Which was first invented in 1984 in Texas, in the USA. A system called Photon, and George Carter, the guy in the middle, was the inventor of it. And you can see those packs. They were quite heavy and robust. You had a helmet, you were allowed to run at people, and they weighed just under 6 kilograms. So they're quite a weight. You actually had to strap lead-acid batteries around your waist. So it's quite a long way from what we're used to these days. There was no laser in the first laser tag system. In fact, it was just purely infrared. And when they had a little LED that lit up at the end of the gun when you fired. So it's quite different. The most interesting thing about this system is it used a system known as reverse infrared, which is very unusual. There's only one system in the world at the moment that I'm aware that actually makes use of reverse infrared. What that means is that when you aim at somebody and you pull the trigger, it actually receives infrared from their vest and then transmits the hit over radio to the other pack, which then goes down. Needless to say, there's a bit of a lag on that, and it can take. And this system, it used to take sort of the best part of half a second from when you hit somebody to when they died, which is a long time when you're playing a game of laser tag. So, and it also was very expensive because it was using radio. So it's a very expensive system by comparison to some of the others. The good bit about it was that if you shot someone, it actually made a noise to let you know you'd hit them straight away, which is something you don't get on a lot of systems. So, reverse infrared. Another commercial laser tag system uses modulated lasers. What that means is the information is carried inside a laser beam rather than being a separate infrared beam and a visible laser beam. So there's only, again, one system using that I'm aware of, and the reason why is because the receivers to pick it up are not commercially available as standard. It's a custom development, so it's very rare. Pretty much everything else uses forward infrared, and the reason behind that is it's very cheap to implement, doesn't require any kind of infrastructure to allow it to work. All you need is to transmit one infrared beam from one device to the other, and the remote device dies, records the hit, and processes it from there. So you pretty much find everything uses forward infrared. So the history of Quasar, the system here, dates back to a news article that was about Photon. So that news article was noticed by somebody in New Zealand, where they created a laser tag system there. Then that was noticed by somebody called Jeff Hazelhurst in Australia, and he went on to develop Quasar from that idea, which he then sold to some people in Ireland. And that's why Quasar is so predominant in the UK as a whole. So the original Quasar wasn't quite what you see before you hear. The vest looked like that. That's one of the only last remaining first versions of Quasar, and it's changed considerably since then to something more like that. So this is the main circuit board of a Quasar gun. I've actually got a couple of examples here, and you're welcome to take a look at them and have a nose around at them. All the components here you can still buy. So this system was designed in the late 80s, and literally every component is available off the shelf to this day, all very generic. The main processor, for those interested, is a Motorola 68HC705C8. Anybody familiar with sort of the Motorola 68 series, it's along those lines. The main thing about it, in a similar way to sort of processors like Atmel, PIC chips and so on, it's everything integrated. It has its own RAM, its own ROM, its own peripherals built into the CPU. So everything is stored inside of that main CPU. The circuit board, because of the age, uses a very old infrared technology. It uses individual infrared diodes to receive the infrared signals. So what happens is all of the little black pieces that you can see around the edge, I can't really, don't know if you can see them there, they're the infrared receivers. They're only two legs. And what that means is that it gets an analog signal that it has to decode into a logic signal. And it does that at the front of the board. So what I'll do is I'll just, that's the main CPU section. I should also, actually, I just realised wrong order. The dip bit switches down below identify the gun ID. So dips 1 through to 5 indicate the number, and then the final dip is the colour, red or green. And that way the guns know who's shooting who. The yellow section is the speech. So pretty much half the board was dedicated just to the audio. And the way it did this was quite clever. It actually used technology taken from telephone systems. So the chip that you see that's going vertical on there is actually a CVSD chip, continuously variable slope delta. Basically what it means is it draws a line up and down based on ones and zeros. So a 1 makes it go up and a 0 makes it go down to produce the waveform. And it pulls it all out of that big speech chip, which is just a normal ROM. Passes it through various filters into an amplifier chip and out into the speaker. Nowadays, you could condense that down to almost nothing with today's modern MP3s. And then finally, there's the infrared section there. Unfortunately, the photo I took, it's missing a chip off the front there. That's actually the demodulator. It converts the analog infrared signal coming in into a logic 1-0, which gets fed into the CPU. The way that the chip generates and communicates was done actually in hardware. They used the serial port to do the infrared communication. So unlike most infrared protocols which use sort of various encoding mechanisms, this system purely uses, if it's a logic 1, it turns the infrared on. If it's a logic 0, it turns it off again. And that's literally it, just straight RS-232. What that means is that you can actually connect a little infrared receiver straight to a serial port and receive your data into it. So it's a very, very simple protocol, and it's effective. It runs at 2400 bits per second, which actually in sort of general infrared terms is a relatively high data rate, and it runs it pretty reliably. So move on to the display board. This is a rather horrible looking version of it because it's been a bit molested in its time. A lot of these boards are old ones, which is the ones I brought along. So basically what this simply does is it's connected over an SPI connection to the main processor to update the display. So the processor does everything in hardware pretty much that it can do, including that infrared comms. The little LED that you see on the right hand side is just the charge LED, shows if it's being charged or not. And this is the front pack and the back pack. So the front pack is the one on the left, the large one, with the big flashy digits that flash when you're playing. and the backpack is obviously on the right. So a lot of this circuitry is purely to make lights flash. There's a little bit in there to do infrared reception and transmission. An interesting thing about Quasar over other LaserTag systems is every sensor area is also a transmission area. And it does that for a couple of features in the game. So what happens is when it transmits, when you're firing, obviously it only fires out of the barrel. When it needs to transmit anything else, it transmits out of every sensor area. It aids communication, but also allows it to do features like bombs. So you can pull the trigger and hold it, and it fires a bomb off from every sensor. That sort of feature. Because this is all done, and they're trying to be as cheap as possible when they design this, they actually only use 6-core cable. They multiplexed the transmission and receive onto one wire for infrared. So the net result is they only need a 6-core cable. And the backpack, as you see, is pretty much just lights and receivers. So just talk you through how how it works when you tag someone. So basically, the red player shoots the green player. Then the green pack stores the hit. It's not the pack that does the shooting, it's the pack that receives the hit that stores it. And it stores it on this system just purely in RAM. The green pack then transmits, and it transmits it from every sensor area, a confirmation that this red pack hit it. And what happens is the red pack can receive that, process it, and let the person know that they actually shot somebody. So I don't know if you can have a couple of volunteers to put on a couple of packs. Go on, come up. Just go. Oh, there we go. 2 people first, sorry. There will be an opportunity later, I think around 9 o'clock, when we'll be actually have this set up somewhere that everyone can play. So large one to the front, small one to the back. That's the large one. That's it. So if you just want to come up on stage once you're ready. You can do the side clips up if you like, but not essential. So okay, so does the red player want to shoot the green player then? So I don't know if you could hear that. Do you want to come over here? I'll do it again. So if you shoot him.
Good shot.
So it announces a good shot. And if you keep doing this.
Good shot.
Hold on, a couple more times. Oh, there we go. There we go. Rapid fire. Go on. Get your own back. Get your own back. Oh. Go on. So there we go. Thank you very much. Oh, that's it. If you just want to take them on. Thanks. So we've introduced the pack and the basics on the pack, but the problem you then get is how do you collect all that information? Because obviously all these different guns know who hit them. They also know how many times the trigger's been pulled throughout the game, and you need to get that information back so you can, let people know how well they did. So the way we do that is with network units, and these network units can act as a number of different things within the arena. So the key one is data collection, so that would be energizers. So what that does is it allows us to collect the information from the pack and transmit it back on a network to a game computer. It also allows us to do things like mines. So you can create these mines that make a load of noise and then fire out and kill anybody near them. Or you can have bases. So you can have team-aligned bases or neutral bases. And you go shoot the base and it makes loads of noise and sirens go off and whatever else the venue wants it to do. So you can see on this unit, There's a couple of power connections there. They're turned on and off depending on what's going on in the game. There's a little D connector there which goes to a scoreboard, so you can have electronic digits showing the scores. And the other connector is the network connection that actually links us back to the game computer. You'll also see a little audio jack which you can put onto a big external speaker. So this is the basic interaction of somebody energizing. So the energizer is sitting there and it constantly sends out these little signals going, hello, I'm an energizer, waiting for somebody to pass by. When a pack receives this little energizer, we call it energizer click. The energizer click is received, the pack will then attempt to download its data. So it will look up all the players who hit it, how many times it's had the trigger pulled, how much time it thinks there's left on the game, things like that, collects them all up, and what it does is it transmits it to the network unit, and if the network unit successfully receives it, it transmits the game settings back to the pack. And what happens then is, depending on the contents of those game settings, the pack will then decide what to do. It could be, if the game time is set to 0 in there, then it will go thank you for playing and turn itself off. Or it could go and make the up sound, as we heard, which is game on, carry on playing. Depending on the game format, some games you have to energize during the game, some games you only energize at the end of the game. It's played strategically, so some games you'll deliberately only have, say, 6 lives before you have to go and reload, to prevent people just owning positions in the arena, camping in one spot, that sort of thing. So the link back from this game computer, well, it uses RS-232. And what happens is, each of the network units is optically isolated. So what that means is that they're completely independent of each other, and it's a single bus. So not quite the way RS-232 was intended to be used, but it works. So what happens is the game computer will know which network units are on the network, and each network unit has its own ID, in the same way that the guns have the dips, the network units have the dips. And this identifies what type of device it is, what data it's collecting, and so on. The game computer simply transmits the ID of the network unit, and the network unit responds back, either with a, I'm here, but I have no data, or here's a load of data for you. And the game computer will then process it. This network operates at the whopping speed of 600 bits per second. So super fast, but it doesn't particularly need to carry huge amounts of data. So part of the reason is in the hardware that they utilise, they probably couldn't do faster, because the CPU only has one hardware serial port, and it uses that for the infrared communications. So there's no hardware serial ports available to communicate on the network. So as a result, it uses bit banging to actually get the data out and back again. So it's a limitation. It also allows it to run very long serial runs without any real problem. So the very low data rate facilitates sort of 100-meter cable runs that I've seen working on RS-232. So it does have its benefits. And of course, it then gets fed back into the game computer, where the game computer processes it into scores, and if you want to scorecard how bad is it? I can talk a little bit about the infrared protocols that are utilised on this. So the infrared, as I mentioned, is purely based around serial push straight out of the infrared. It's modulated, and it does this via using the ripple counter, fed directly from the crystal that drives the CPU. So they've really been economical with what they do, because the ripple counters count down for things like the speech, they count down for a variety of other, the chasers on the sides of the guns, everything is driven from the crystal timing. The data format is actually very, very simple. You've got 1 byte, which indicates the packet type, followed by 1 byte, which is, in the case of a shot signal, your gun ID, followed by the 1's complement, so all the bits are flipped on the second byte, on the third byte, compared to the second. So that is a shot signal, and the good shot signal is exactly the same with a different message type. The gun download and game settings, because obviously there's more data, you can't do the 1's complement, so they use CRC16s. So they've all got, every time it just calculates the CRC16 and transmits that. So that's sort of very basic idea of the download. The CPU doesn't have that much RAM. It has sufficient to handle 40 different gun IDs. If you try and put more than that in, then it runs out of memory. So the system's capable of doing 60, but the CPU itself, when you get to that 40th person hits you, it just turns itself off and goes, you've got to go back to your Energizer now. A limitation of the CPU, which we've hit. The other thing to note is with all the infrared systems, the shots have to be focused. So that's the little lens that the Quasar uses to focus it. Other systems use different methods to focus it, different lens arrangements, different sizes, and so on. Now, because it's an indoor system, you're never going to be firing that far. You don't need something too powerful. If you use an outdoor system, you get something more like that. So a much bigger lens, can fire much further, and you can get sort of 200, 300 meter ranges out of these. So that pretty much sums up how the Quasar system works. So the question is, what's next? And the answer is Wi-Fi, of course. So this is the first prototype of Wi-Fi module for Quasar, which I've been working on. You'll also notice, although I haven't connected it, the module on the left is an RFID card reader for a membership system, and the connector on the bottom is an iButton reader as well. So it's sort of does all sorts of bits and pieces in this, and uses the MiFi module from Microchip to do the Wi-Fi, and that successfully works and has been tested. Just needs a bit of refinement before it's production ready and will go live. So there we go. Incidentally, the reason I'm wearing this orange top, I should mention, is because a crew member of mine moans about the fact she has to wear orange and wanted to wear black. So as a result, that's why I'm wearing it. So Meg, when you see this, there you go. So that concludes it. So if you have any questions. Is somebody going with the mic? Okay. Okay, so definition of cheating by covering packs. For a start, you have to agree that that's cheating or isn't cheating, because in competitive laser tag, Quasar is one of the only systems that does permit covering of sensors. Other systems generally don't, or have certain rules regarding touching the plastic, but the Quasar system is one of the ones that actually actively permits it. As far as actually blocking and disqualifying somebody for doing so, that has to be one of the hardest things to, I can't think how you'd easily do that sensibly. Anyone else? Collisions between different transmitters. If two people fire precisely at the same moment onto the same target, then yes, you will get a collision, and the tag probably will not register. However, generally speaking, the tag time length is very, very short. You're talking sort of, I think, 20 milliseconds. So as a result, trying to get the timing, especially when we're talking about typically where it's played, say, 1 or 2 shots a second, Those things don't generally cause a noticeable issue that I've seen. The energizers typically are sort of put away somewhere, so and generally they're designed so that only the person in front of it will actively communicate with it. So there's not a huge amount of sort of broadcasting going on in that respect. It's definitely possible, but it's so kind of rare that it doesn't really cause an issue. Anybody else? Yep. The main reason for adding Wi-Fi is to aid game turnaround time. So at the moment, what happens is at the end of the game, you have to download. And at the start of the game, you have to load up. We've already got a workaround slightly, which is an infrared automatic downloader that sits in the pack room. So what happens is when we hit game start, all the packs turn on. And when they come back in, it downloads them. But because of the nature of it, it's very difficult to make that work 100% reliably on the download at the end. Startup's fine, but the download at the end can take a couple of minutes. So as a result, it hurts the game turnarounds. So by putting Wi-Fi in, the game ends, all the packs download straight away. You don't need to worry about it. Plus real-time scoring. Okay, so Laser Quest works. The Laser Quest system works via radio. So what happens with Laser Quest? It's one of the earliest radio systems that's still in use today. So it's actually a very, very slow radio system. What it does is it has to poll every pack individually via quite a slow radio and align it to the game, and then it transmits a broadcast game start, so all the packs then start up with the game settings. But it basically checks every pack into the game first. And then when it hits start, all the packs individually time the 30 seconds so to game start.
Do you ever go to like a Quasar game with your little pack program?
This one, the mini-gizer. We call that a mini-gizer, by the way. No, because that would be cheating. And I mean, in all seriousness, there's tons of things you could do that you can have a laugh with, as long as you're not taking it too seriously. Some of the little projects that I've created in the past included a thing called a good shot heaven, as I called it, and it's a little transmitter that constantly gave you good shots every time you pulled the trigger. Irrespective of whether you hit anybody or not. And in certain games, you get rewarded for that by getting supercharged, so you could fire faster and then hit the base. So there was a few little things like that, but never in a serious game.
What are the issues are with the general sort of reliability of the packs and the clubs? Because I've played Quasar and Laser Tracks for a few experience quite a long time. Yeah, there's some bit of reliability of the packs and things you pack. It's really questionable. Like, you play one game and it'll be fine, and then you'll go back to one time and have a different pack, and you'll be terrible at it. And do that down to the 10, like some of the packs will be a bit on the wrong. So, like, what kind of things go along with it? How to get around it?
Well, yeah, pack maintenance and general repairs is probably my personal bugbear for visiting sites myself. I've visited an awful lot of arenas, and the quality of the equipment varies dramatically, and it really is down to maintenance. Because if you think about the fact that you've got wires running through this that are constantly being moved around, then what happens is they break, and if they break in certain ways, they have different effects. So you might lose the infrared cable, in which case you can't be shot in the front or back. Slight advantage. Your gun's still available though, but nothing else. So it makes it I say, very unfair when you come across sites that just don't maintain their packs. Some systems are more prone to it than others. This system has its own fair share of issues. But to be honest with you, we've kind of engineered most of them out on our equipment now. So the sort of on that display board, it's not one of ours that we would normally use, but the wires on display board flex and come loose and short out and cause faults, things like that. So there's definitely reliability. There's some systems I'd say are definitely a lot more reliable than others. I'd say probably Laser Force tends to be one of the most reliable that I've seen. Others can be quite variable.
If you went through Wi-Fi, something there's people wouldn't be available and support for the lockpicks as it's going to sit in the car park.
So, as far as the Wi-Fi goes, we're using WPA2. So I'm hopeful that nobody's going to hack that, providing I use a sensible long encryption key. It's always possible, and in theory somebody could go in there and try and pinch the network cable out of one of the access points. That sort of thing probably isn't unheard of, but to be honest with you, all they would get access to is the game computer's ports into the game system, which has security on it anyway. So they could pretend to be a pack and start playing games, perhaps, but I can't think what enjoyment they'd particularly derive from that. Yeah.
How does the game control software deal with integrity issues, for example, the confirmation signal not making you perhaps got push fire initial shots?
Oh, so are you talking about just firing?
Yes, the confirmation.
Okay, so the pack who receives the signal, the shot signal, dies and sends the confirmation. It stores the hit data inside of it. So that's the data that goes into the scoring in the game computer. The hit confirmation that's returned is purely there as an additional bonus. And it's, as I said, in some games it rewards you by giving you supercharge and things like that. Anything else? Oh, yep. Sorry? Well, the system already has smart bombs, so you pull and hold the trigger in, and it will fire a bomb out of every sensor area that you've got, so it'll kill anybody standing around you. Kind of brings me on to one of the features that I would like to add with Wi-Fi, which is a nuke. So basically, you pull the trigger and hold it, and it kills everybody in the arena. Okay, anybody else? Okay, so normally with the questions are, what is bit banging? So what normally happens with the hardware-based serial ports is that you give a byte of data or two to the serial port hardware, and it goes away and does the transmission for you. You have no more involvement other than it comes back to you and says, "I've done it." Bit banging is where you're not using the hardware and the software is turning the pin on and off for each bit manually. So your software is actually driving each individual bit in and out of the processor. So it's quite labour intensive in terms of CPU time, especially with these. They're running sort of about 1.4 megahertz. So, okay, anybody else? Oh, yep. Okay, so LaserTag, obviously, there's a lot of manufacturers out there. So the LaserTag business is actually, on the manufacturing side, is very competitive. The UK currently has Darklight is a home manufacturer, and there's a couple, Q2000 still manufactures, and Quasar still manufactures. However, there's a bit of history that I didn't go into with sort of Quasar, the actual business. So after the Irish bought the system and started selling it, they licensed it to a company in the USA who couldn't use the name Quasar because it was already trademarked. So they went in the name Quasar. So, as per this. And that company did really well initially, and they actually bought the Irish company out. So they end up owning the whole rights everywhere. Unfortunately, there's a variety of stories of what went on, including various drug habits and sort of money going missing and failed ventures. They tried to develop a new generation, and by the third attempt at making the new generation, it was a horrible failure. They actually had it at I think the Atlanta Olympics. They tried to push this new system into there, and it didn't work, so it was dropped. As a result, the company went to the wall in the late 90s. So the original manufacturer gone completely. However, the unusual thing about the Quasar business model was that the equipment was mass manufactured. They had literally thousands of packs still in stock. So there was a huge amount of equipment bought up by a few different organisations. One of those organisations was the UK distributor who carried on selling and supporting the sites in the UK. They then produced their own hardware, which actually was just this, but with new plastics, and called it Quasar Elite. And that is still actively being sold today. I don't know if there's... I don't know what the future holds for them. They keep talking about a radio system. We're yet to see it.
So, even though the UK distributor now supports the sites in the UK and got new plastics, the electronics in it, the hardware, is really a legacy design pretty now.
Yes.
Dating from the West.
It was the early ones were late 80s. I think some of the Energizer boards copyright 1990.
Right, and they're still managing to manufacture them without parts obsolescence.
Correct. All the parts are still available, completely available. The only exception is I think the display driver is only available in surface mount now. Yeah.
How accurate is what sort of coverage areas and focus is ready out to canvas to where the laser says you're working? Is that reliable between guys?
That probably depends on the tech, to be honest with you. But the Quasar is probably what you'd call a shotgun. It's got quite a wide beam. Compared to some of the other systems like Darklight, which has a very, very tight beam, you have to be very accurate with that system. This system, as long as you generally shoot around the vest area, you'll probably get it. So it's quite a wide beam comparatively. The laser alignment, because of the way they're set, the infrared emitter has to be in one spot and can't move. So that's always there. The laser depends on the assembly they've used, because we've made our own assemblies to put in there that have the laser pointing straight forwards. But some people might not be using lasers quite so well put together. So don't always rely on it. Anybody else? Yeah, so Laser Rush is my site. We're based in Whitstable in Kent. So it's just one site, but there's a friend of mine does all the tech work for me, and yeah. Cool. Anybody else? Oh, other one. Sorry, I can't hear you. Yep. The real problem with that is I can make one board with quite a lot of simplicity. So the software inside that board is a very small PIC chip, which just negotiates which bit of data flows where. Literally, it just organises the flow. The Wi-Fi board purely is a serial port through to the game computer. So all I need to do is repurpose the code on the game computer to talk slightly differently through to the gun, and it will communicate quite happily. If I have to change it, then I have to change every single component, because the whole system is based around 5-volt logic. And the receivers are all based around the old style receivers. and the honest truth is I don't have the experience or the interest to go back and redesign the infrared decoder and things like that. So there's a lot of things that would have to be changed, and it would actually be a hell of a lot more work overall. It is something I'd be interested in, but this is about getting something going quickly rather than. I mean, literally, I went from idea to working prototype in about a month and a half, so it's pretty quick. Anybody else? Oh.
So someone else just sort of asked me the answer started talking about the technical stuff. But in terms of the LaserTag business here, my feeling probably is that it's been strong in the past few years. So I think around looking for making stuff right, or do you think it's growing elsewhere? Like how
Okay. So you're talking about the actual venues themselves rather than laser tag manufacturing. Okay. Well, it's very difficult to compare because sort of I've been involved with my site for about 5 years, but when I took it on, it was in a very poor shape. So the only hope was that it would go up. So from a business perspective, on my site, we've seen increases. Whether that's reflected elsewhere, I don't know. What I do know is that, comparatively speaking, the UK is one of the cheapest places to play in compared to other countries I've been to. So, yeah, it's in terms of money making, it's probably not a huge money spinner. Hi. Okay, so yeah, more game formats are possible. Switching teams, unfortunately, would involve changing the plastics and the LEDs on this system. Yeah, I mean, two sets of LEDs, unfortunately, would require new boards. So it's one of those things that, yes, I wish I could do that, but that's kind of part of my let's redesign the whole system in a few years' time. But yeah, definitely more game modes. One of the key things is that the energizers can only store one set of game parameters. So there's no way of individually targeting the game type to the individual player. So say, for example, I want to give one particular player a particular role in the game. I can't do that. I can only do it, but sort of one set for everyone. The advantage of Wi-Fi is that potentially I could send different settings to different guns on an individual basis, and then we can have role play. Yeah, it's possible to do. Definitely possible to do. Yeah. Do you remember where it was? I believe Hangar 51 utilises Q2000, which is definitely not radio based. Does it have a weapon selector button on it? Weapon selector button on it. In which case, yes, it's Q2000. It's not Wi-Fi based. Q2000 you can get power-ups off different arena devices. That's all infrared based. You fire at the target and it will give you a power up of like more armor piercing or something like that. Okay. Okay, Q2000 has a relay system. So what can happen is the pack, because it's based on Q2000 is actually based around this exact same hardware. They've redesigned the board, but the actual technology is identical. They've just surface mounted as much as they can. And what they do is everything it receives, it can retransmit. So if you stand underneath a base station, it will transmit out the game settings, and your pack relays it to everyone else. And it just daisy chains its way down. anymore. Okay, thank you very much then. I hope to shoot some of you later.